Assalamualaikum warahmatullahi wabarakatuh. My name is Eli Ardila binti Nasaruddin. My matrix number AE190074. In this video, I will present the FYP1 project, which is solar grass cutter fully automated using Arduino. The problem statement, which is chapter 1, is most of the automatic grass cutter runs on battery and require frequent charging at nearly 1 hour. Charge after usage become inefficient for grass cutting operation. So, to overcome this problem, we need to implement solar panel application as energy source of batteries. And then, the problem statement number 2 is manual lawnmowers required a lot of strength and energy to operate, make it unsuitable for the disabled and elderly. So, to overcome this problem, a fully automated lawnmower is required for the group of people stated above. Next is objective. Our objective in this project is to design and build a grass cutting system using Arduino-based circuit to control the grass cutter in automatic operation. Next is to develop RC car mobile apps for wireless robot control. And third is to improve the battery operation time for automatic grass cutter by using solar panels. Our project scope is our size cutting robot system is compact and easy to control with dimension 340 times 132 millimeter. Our specific solar panel will be used is 18 volt 10 watt polycrystalline PV solar panel with dimension 350 times 240 times 70 millimeter. And then for the movement of solar grass cutter robot, controlled by two methods, which is start button and RC car mobile apps. Next, this project is intended use in small and fenced area for obstacle detection by ultrasonic sensor and recommended such, which is home garden, small farms, and nurseries. For next chapter is chapter 2. So in this chapter, which is literature review, we find the component used for this project. For the component used, we divide into the two components, which is hardware and software. So we talk about the hardware first. So they use 8 component, which is Arduino Uno microprocessor, and the function is to programmable open source microcontroller. And next is Bluetooth module HC05 to set up wireless serial communication. And third is solar panel to absorb the solar ray, which provide an energy source for generating electricity. And the fourth is battery to supply energy to the circuit. And then we use ultrasonic sensor HCSR04 for obstacle detection. And then DC motor for movement of wheel. And then we use motor driver to control the speed and direction of the vehicle. And last one, we use servo motor for rotate with great precision. Next is software component. First software we use is Arduino IDE software to write the coding of the Arduino Uno. Next is Proteus 8 professional software to create circuit and schematic diagram. And we use SolidWorks software to draw the prototype design. And the last one is Bluetooth RC car mobile app to control car movement by using Bluetooth path. Next is previous research. In this previous research, we find the 5 journal. So first journal is PID controller based automatic solar power driven grass cutting machine. The method they use is they use color sensor TCS 3200 for grass detection. And then this is the component used. And for the finding, we got that when we use color sensor, any dust or clay need to be wiping out to prevent malfunctioning. And the angular speed of the blade need to exchange due to density and type of grass. Next, journal is autonomous solar powered grass cutter. And the method used is using BLDC motor for much wide area coverage. And this journal design sheet at the front to patch away small object that HCSR04 isn't able to detect. And then they use 2 battery, which is LiPo and lithium ion. And for the finding, we got that design that details are important to produce a product that meets the needs and use 2 different battery sources for maximum operation. And third journal is design of remote monitor solar power grass cutter robot with obstacle avoidance using IoT. And the method used is this is the component used. So if we can see, they use 3 different RPM DC motor, which is first is 600, 400, and 4600 RPM. And then they use Bing app, which is RC car controller Android app. And for the finding, we find the the different RPM used of DC motor for maximum speed. And the fourth genre is automated solar grass cutter, which is the method they use is this is the component used, and then they use a Bluetooth controller. And for the finding, we find that circuit diagram of solar grass cutter and also the basic component of solar grass cutter for project. The last journal title is Solar Powered Automatic Pattern Design Grass Cutting Robot System using Arduino. And the method used is they use two mode application, which is start button and voice recognition for off mobile apps. And they use 600 RPM DC motor and 46,000 RPM for blade. And they use MIT App Inventor for mobile app control. And the finding, we find the coding pattern design mechanism, and we find the connection of 5 DC motor to L233-293D. Next is chapter 3, which is methodology. So, phase of methodology have 4 phases. Phase 1 is project planning, include title selection, identify problem statement, objective, and scope of the project. Next, literature review and proposal making. And for the phase 2, which is circuit design and analysis, it include flow chart, circuit diagram, wiring connection research, and installation wiring. And in the phase 3, which is hardware design and testing, it's include prototype design, prototype installation, and project improvement. And last phase, which is phase 4, is report writing and documentation, which is phase to complete the chapter 1 until 5 and report submission. And for the flowchart of project, first, we need to identify the problem statement and objective. Next, we need to make some literature review. Next, we need to design the circuit diagram and coding. Next, after design the circuit diagram and coding, we need to test the circuit and coding. So, if some problem have in the test circuit encoding, we need to move to the literature review back, and then if no problem in the test circuit encoding, we need to continue to the installation complete hardware. Next is to test hardware and collect the data. So, after test hardware and collect the data, we need to identify which is our objective was achieved or not. If not, we need to back to the installation complete hardware. And if our objective is achieved, we need to start make writing final. Next, which is flowchart of solar grass cutter. So this flowchart shows the technical process of fully automatic solar grass cutter using Arduino device. Solar panel function as power source for battery to remain the time life. There are two modes of transmission and control of the solar grass cutter, which is first is use the RC car application that have been downloaded on the mobile phone. In this system, when the user press the corresponding touch button, the signal is transferred to the Arduino Uno mounted on the car via a built-in mobile Bluetooth device. After receiving the following signal command, the Arduino will check the signal with the predetermined command program through coding and send the following signal to the motor module to move the robot and the process of mowing the grass. The second mode is to control the robot car fully automatically by pressing the on switch button, the robot, and place the robot at the starting point position to cut the grass. To stop the robot, the user just need to press the switch off. Next is flowchart of movement pattern algorithm. So from the starting, the device will move and start the grass cutting process. At the same time, system will initialize all sensor and microprocessor to detect the obstacle from front, left, and right side. When the ultrasonic has detected the obstacle from forward, sensor from right side automatically function to detect the obstacle from the right side. If sensor decide that no obstacle from right side, sensor will double check the obstacle from forward before checking the obstacle from left side. Then the device will turn left twice in between 5 minutes if no obstacle detection from left side. At this time, the device are in straight line of second layer of area. The device will continue to move forward and cut the grass until it found the second obstacle. Next, if the ultrasonic sensor has detected the second obstacle from forward, the process will repeatedly check the obstacle from the right side. If sensor detect the obstacle from right side, sensor will double check the obstacle from forward before checking the obstacle from left side. Then device will turn left twice in between 5 minutes if no obstacle detected from left side. At this time, the devices are in straight line of second layer of area. The signal is transferred to the Arduino Uno mount on the car via a built-in mobile Bluetooth area. After receiving the following signal command, the Arduino will check this signal with the predetermined command program through coding and send the following signal to the motor module to move the robot and the process of moving the grass. At this time, the devices are in straight line of the second layer of area. The cycle will repeat until ultrasonic sensor detect the obstacle from front, left, and right side. And the following movement pattern algorithm has implemented from design below. Next, we move to the block diagram for circuit connection. So for the circuit connection, we have Arduino motor driver, ultrasonic sensor, Bluetooth module, 3 DC motor, servo motor, and the last one is batteries. Next is prototype design, which is we use SolidWorks software. This is the front view sketch, rear view sketch, and side view sketch. The shape of the sketch is created with a small and compact size to make sure it is easy to control. However, this is not the final prototype in its real form because there will have changes when prototype implementation to the actual prototype. The overall length and width of this project includes solar panel and wheel are 340 times 132 millimeter. Next, we just chapter 4 with preliminary result. So this is the development of hardware. In this SEM, we have been installed ultrasonic sensor, servo motor, Bluetooth module, with DC motor, motor driver, Arduino Uno, and also the body frame. For the solar panel and blade, we will install for the next semester. Okay, next, which is development of circuit diagram. So if you can see, we have made a circuit connection of batteries and motor driver to the Arduino Uno, DC motor, Bluetooth module, servo motor, and ultrasonic sensor. But for the ultrasonic sensor, the sensor has put in at the head of the prototype. Next, which is development of coding. So we are make the coding of this project using Arduino IDE. So here the project, the coding. Next, which is testing of component. So for the testing, we have make two testing, which is first is testing for robot movement controlled by RC car. So the picture we can see movement to the forward, left and right, and reverse that controlled by the RC car application. So the result is for the movement, Moto 1 and Moto 2, for forward, Moto 1 and Moto 2 function very well, and for the reverse, Moto 1 and Moto 2 function very well, and for the stop, Moto 1 and Moto 2 function very well, and for the right and left, Moto 2 function, but not enough speed, so it need to the improvement for the next semester. Next is testing for the Bluetooth module HC05, distance and signal strength testing. So testing has been do for different distance, which is 1 meter, 5 meter, 7 meter, 9 meter, and 11 meters. So the signal strength result is for 1 and 1 meters, the signal is very strong, and for the 5 distance, the signal is strong, and for the 7 distance, the signal is weak, and for the 9 distance, the signal is very weak, and for the 11 distance in meter, signal strength is unavailable. For the last chapter, which is chapter 5, which is future work. For the future plan, first is to build the complete grass cutting system using Arduino-based circuit to control the grass cutter in automatic operation. And the second future plan is to improve the battery operation time for automatic grass cutter by using solar panels. Thank you.